Look at that. What day is it? It
Hey, Ziti
is
TV.
Ziti TV time,
Hey,
Ken. It's
Clint.
time. Hello, how are you?
I'm doing well.
I'm
Happy
glad to hear
Friday.
that. Happy Friday to you, my friend. Day before the weekend. Hopefully, it's going to be nice here. I don't know where you are or when you are, right? Whew, you never know when somebody's watching this. Um, so today on ZD TV, we're going to do some the same stuff we normally do. I was just talking to my buddy Paul about the change logs, so that I could speak modestly, intelligently about it. We'll see how that works out because you never know. And then maybe we'll take a look at some other stuff. But how's the week been for you? It's been pretty good.
Yeah, it's been quite a. It's been like a kind of like a firestorm.
Oh no, a good firestorm.
Yeah, I mean we're doing the right work. We're doing the right work, so it's like really important that we keep bringing the pain forward and finding issues and thinking about how this is going to impact scale and reliability down the road. So it's all
So like
good
a
stuff.
work firestorm. I see. I thought you meant like outside of work. All right. Well, let's dive in, shall we? Let's see.
Let's do it.
Here's my little slide. I try to make a bumper so that people can see what it's all about. Let's see if I can get rid of that TV. How do I get rid of the TV?
Two releases in 1 week. I'll take care of it.
I I keep trying. I don't know where it's going.
I'll get it. I'll get it.
Well, you'll have to inform me why my clicking didn't click the thing correctly because I had it clicked. I
Uh,
unclicked it, and then I clicked it
yeah, it's
again
like
and unclicked it. It just didn't want to do it.
there's more than one of those, and one's on
So
the left, one's on the right. That's what's going on.
yeah,
Yeah.
is it under the logo? Where's it under?
Overlay
Overlay.
in the
I
studio.
see.
Yeah, yeah,
I see. Oh, it's down up. Hey, there it is.
yep,
I
yep.
got it.
You
I
found it.
got it. All right, cool.
Button pusher.
Two releases, not in 1 week. Absolutely not.
Oh yeah, we were
Um,
2 weeks.
I think it was more than that, to be honest. We didn't do a ZDTV one of these weeks, but it's been a long time since we've had some release notes. This
And this is like a these release versions are for the whole kit and caboodle of controller, router, and lots of
Yeah,
ancillary software, right? So it's kind of like this is your convenience version that lets you keep track of like the whole system.
can we take a timeout for a second? What was that
Sure.
big word that you used that started with an A?
Big
A
word
N
win.
A N C I L L A R Y.
Ancillary?
Interesting. I wonder if this is a regional problem. I would say ancillary. It's kind of
Ancillary.
yeah.
Yeah, I think
Wow.
that's probably I'm a Southern man, so
I love
probably.
it. I love ancillary. I thought you were talking about salary. The celery, the little green thing that you eat. I was like, I was very confused for a moment. All right, so yes, it is. These release numbers is the full kit, and sometimes things in the kit change, and sometimes things in the kit don't change.
And if
In
any
fact,
one thing changes, that's a version.
yeah. In fact, you'll see that with version 25.6 there,
Right.
because the only thing that happened in 25.6, other than one teeny tiny bug fix, is we're moving to Go 18 or 1.18. But
Okay.
it is the full kit and caboodle, and that is actually feedback which I have provided to the team when I read these release notes, because do the change log right here. Because the change log, I'm going to embiggen that.
Yeah, I'm big
All
in
right.
that.
So you can see in Go 25.6, we only changed from Go 17 to 18. And is that embiggened enough, you think?
Yep. That's
Yeah.
good for me.
And then you'll read down through and you'll see all this big long change log. I'm going to probably try to skim through that relatively quickly, but the feedback I provided would be that it would be nice to have kind of the same format, but for each of those individual components that may or may not have changed. I don't think we need to see a nothing changed option, but like ZD Fabric, for example, it'd be nice to have a section on just things that are related to the fabric, just things that are related to Edge, just things that are related to SDKs, et cetera, et cetera. So,
Right.
without further ado, here's our big long list. I'm going to come back to that once in a while, but I actually pre-sorted it on my own. So I'm going to bring that over here because these are the enhancements that have happened. So is it big enough for you? You good?
Yeah, it's readable.
All right. You
Totally.
seem a little dodgy on that. Should I go bigger? All right,
No,
we'll
I
go
was
bigger.
no, you're good.
So here are the enhancements. Let's just walk through them real fast. We've got support for M1 in our quick starts. First few things are about the quick starts. If you haven't used a quick start, go try them out. Hopefully, they're really easy to get going. And if they're not, then please put an issue in GitHub, sign into Discourse, and slander them. Tell us what's wrong because these quick starts are meant to make it easy for you. And if something's missing, then we need to know. But we do have one fella who should really enjoy that top bullet point because Chris has been having this particular problem probably forever. And now that Mac Silicon is in more places, it's important to get the quick start to work with Mac Silicon as well. So that's cool. A couple more quick start related changes, a couple of bugs that are in there. Then there's a new neat one, external JWT signer, issuer, and audience validation. I didn't get a chance to talk to Andrew about this, but
Whoa,
the it's
that feels like a big one.
it is interesting. I'm going to go back to the actual README for this one, so we'll skip it for now. But there's that.
Okay.
The ability to define local interface binding for link and controller dial. This is pretty cool because if you have multiple interfaces in your machine, you can now add multiple dialers for the actual interface which you want to dial out of, so that you can provide redundancy on your links. That's pretty
Yeah,
neat.
this will
Um,
enable multi-WAN for a router, correct?
you could look at it that way. I don't know that that's the intention. I think it's more about HA than multi-WAN, but that
Right.
is an option.
Like multi-circuit. So you have redundancy of circuits with discrete binding for
Yes.
each configuration.
Yeah, but it is marching toward that better control over what routers can dial what routers and what routers listen on what interfaces and that sort of thing. So it is marching toward that sort of multi-WAN control that you're talking about. But I think this is probably more for just HA and being able to actually control what interface you're dialing out of. Also costing, I suppose. How expensive that interface is. If you're going over mobile and you're on Wi-Fi, you probably want to use Wi-Fi over your mobile as a precedence. Um, let's see. We've
Oh,
got a
so
new.
you could bind a terminator. Sorry to belabor the point, but you could bind a terminator to a particular binding. I mean, you could couple a terminator binding with a link binding, is what you're saying,
Well, you
so that
can
you
you
could.
can already you can already yeah you can already kind of do that sort of stuff, right? Like that. This is
Okay.
this is just allowing you to specify what interface you dial out of, so that you can choose where you are establishing your link from and control the costing on that. Like, I
Okay.
don't know if you can actually do it yet. You probably can, but I don't know for sure. So I'm going to say I don't know. But yeah,
Got my
that's
gears turning on that, so we can come back
yeah.
to it later.
Maybe we'll come back to it way later. I don't know. Maybe we will get through the change log. All right. The next thing is this ZDB Explorer. This is a support type of feature where some sort of problem happened and you don't understand why. We use a database that is called Bbolt, Bbolt, which is a file on your file system, and it's not particularly friendly to your typical database tooling. So this is a customized version of accessing that database, which lets you explore the database. Probably not relevant to most people, but neat if you're doing support. List commands, most list commands, I like not making any promises. We got most of them probably are now tabular, as opposed to probably spaces. uh, ZDEd show has some subcommands. Update config types, create update now supports external ID, which I suppose is probably going to be used for the external JWT signers. Minimum router cost, that goes back to the fabric. Express instance and link send buffer pointer. That's more debugging stuff. Same is probably true for how many go routines you can see. That's all going to be more, debugging type stuff. Um, there was one up. I think I skipped it. The management API. Yeah, yeah. The management API is now available over a WebSocket. So there used to be a legitimate, normal not socket that you would attach to for ZD Fabric streaming events, and now you can attach to the management API and upgrade a socket and get a web socket and do the same sort of streaming type of stuff that I've actually never played with or don't quite know what it's about. We got some chat. We got something
That's just
from
me.
Wash Hands. Wash Hands. Nice. All right. Let's see what else is interesting. Managing the go routines. If a router connects to the controller, it's already. Oh yeah, this is neat. So if you reconnect your controller and for whatever reason, or your router, and for whatever reason the controller thinks you already have a link, the last one in wins now. So basically, if you reconnect your router and there's maybe a stuck socket open causing troubles, it won't be a problem. Your router will still connect. Some flow control changes. These are all around speed and resiliency, making the fabric better. When the router connects to the controller, reestablish. This one I think should have been filed under bugs. So it says when you reestablish connection to the controller, the router will now make sure that you're in sync. That's good. That seems like more of a bug, but we've renamed the push dev build to build local dev, which is a much better name. I totally take ownership of the terrible script that I called that, and our buddy Jeff fixed that for me because that was a mess.
Thanks, Jeff.
Thanks, Jeff. Right. Some bug fixes. Fixes an issue. I got my. In case anybody wonders, I got my mic down here and it's occluding my monitor. So if you see me doing these kind of things, that's the reason. Like the mic
Not
is like
actually
literally.
dodging
Yeah, I
insects.
got I got I got the teeny tiny screen here so that it comes through in perfect 1080p for the people watching this. However, it's right in the way, and maybe I'll figure out a better way to do this in the future. Let's see, fix an issue where Edge administrator checks would not take default admin flag. Oh yeah, that was an important one. Um, Fix an issue where Docker Compose quick start. Okay, quick start fix is admin would always default to false. Yeah. Identity external IDs not properly rendering. Issue louder. Yeah, we've got some bugs fixed. So that's our change log. Let's go back now and take a look at I want to start with this one. This is the ability to define local interface bindings, what we were talking about, where you can now say, what IP, which would be bound to an interface that you wanted link to be dialed out of. So now you can control that in your router's configuration.
Okay, so this is ZD router config YAML,
Yeah,
and it
that's what
has
this
that.
is.
Okay.
Yep. And then there are link dialers and link listeners. You can always have link listeners on different interfaces, but now it's the dialing that is new and improved, so to speak.
I see. So you can bind to a particular NIC the controller channel. That is how it talks from the router to the controller, where it reaches out. You can tell it to always
Well,
use that wireless interface.
it looks like that, yes, which is interesting because I didn't realize that. But yeah, you can. So that's the name of the interface there. That's
Yeah,
not
the
that's
device
not
name.
the that is not the IP address of the interface, and the dialer is using the IP address and not the interface name. I'm not.
Probably to illustrate that both are valid for that.
I'm gonna go with that, Ken. Yeah, I don't know that that's true at all. Like I would like to know that. So if any of our Fabric friends are out there listening and want to toss on the chat whether the bind can be either interface name or never. You know what? Hey, Ken, just tell me to read the doc. It's right there on the screen. The interface can be provided as either a name or an IP address. It's just
There you
proof in the
go.
pudding that not every developer reads the doc, right?
Who has time to read everything?
I don't have time to read anything. Come on, I just want to see it. I want to just give me
What?
how it works. So yeah, apparently it supports both. That's awesome. That's pretty cool.
That is pretty useful.
Um, External JWT signers. This is something I should have talked to Andrew about earlier. I did not get a chance to, but um, what
I
what would be useful for me, and I don't know where if external JWT signers are actually following. I just need like a little why why we did this.
So
We
I
have,
I have I have the high level.
you know, the high level. I see the
I've got the
what,
high
I see the
level.
how.
Yeah.
I just don't see the
Okay.
why in here.
So you want to be able. It's like having a. It's an external identity provider that can rubber stamp bearer tokens with a digital signature. So you have to configure, just like you have to configure the controller to trust third-party CAs to issue long-lived or short-lived certificates that are then trusted to become identities. And he says, Andrew says, it stops JWTs from being used across intents. So,
That's the what. That's not the why.
but the why is so that you can have, just like you get an API session token, which is a bearer token from the controller. This gives you other third parties that can also issue session tokens, if I understand
Yeah.
correctly.
Yeah. That's pretty neat, right? So now you can obtain authentication from some other location that is
Right.
not exclusively the ZD controller, which
Right.
is
And it
neat.
may be other forms of identity because ultimately what you're doing with the certificate is getting the JWT, right, in order to represent your session. So subsequent connections use that as the bearer token.
Well, I'm going to claim ignorance on that one, Ken, but I think that we get the gist. I mean, if we don't, maybe Andrew will. I can only imagine Andrew stewing right now. All right, so that's the that's the reading of the changelog. The next thing on my little docket here that I was going to do is I was going to use Ziti TV this week as a way of providing short little clips that we will edit and put on the YouTube channel by itself that just cover the superpowers of OpenZD in an application embedded world. And in fact, maybe I'll even start with a tunneler because I think the tunneler's superpower is really cool, and it's one that is not. I don't know if anybody else that does it. To be honest, Cloudflare kind of does it, but all right. So how this session will go, Ken, is I will inform you of a superpower of OpenZD, and then and then I see Andrew's comment. That's great. I see a superpower. I will inform you of a superpower, and then we'll talk about it, and then we'll rinse and repeat. And that will be we'll do that for however many minutes that takes, and then hopefully we'll get down to the discourse topic of TLS all the way down, because that was something that came out recently on Discourse. We had a user who was exploring OpenZD and said, "Hey, if you offer me end-to-end encryption, how is it that I'm not getting end-to-end encryption? Why do I not see the padlock?" So we'll get into that if we can get into that. All right, first slide is here. Ken, allow me to present to you a superpower of OpenZD. And why do I have tunneler spelled wrong? Right, I have tunneler spelled wrong. Oh no, I don't have it spelled wrong. It's just a casing issue. Tunneler. I don't want to see that. That makes me feel better. All right, and it is superpower of OpenZD tunnelers, private DNS.
Basically, bring your own DNS. Don't worry about global DNS. No reliance upon DNS infrastructure. It ships right there with the code.
That's right, and it's still I would say in some ways it relies on DNS infrastructure because there is a name server that is somewhere that satisfies these DNS queries, right? So in some ways it relies on DNS, but it doesn't rely on the global DNS. This is totally private, entirely local DNS. And on top of that, it's also authenticated DNS, which means if you wanted to create an intercept, which is something like this is capture the flag B sides. Let's just change this to ZD dot. No, actually, let's do HTTP dot ZD. That's one I use a lot. To any of these domains which don't actually exist, you can actually copy or create, not copy. You can create these DNS names all on your own, and they're only accessible if you're running an OpenZD tunneler. So does that spark any thoughts or conversation from you?
Yeah, it makes me think about the. So when you say authenticated DNS, what that tells me is that this little name server that comes with my services. It's tightly coupled, so that's always true, but it's also authenticated in the sense that it's going to create an IP listener, like a name server IP that's only available to me, and any answer I get back from that is true.
Any answer you get back is true. No,
Right.
that's not quite right.
Like
So,
it's
like,
authenticated in that I can trust the answers I'm getting back from that name server that's part of
if
my
you get
desktop
an answer
configuration.
back that is successful, okay, let's say
Right.
that a different way. If you query that name server that is provided by that tunneler on your operating system and you get a response, that response is authoritative for you for that
Correct.
time. Absolutely.
That's a good word. That's actually a DNS term, authoritative versus recursive, I think.
That's another term.
Yeah. Right.
so
Well, the
so
idea being that by default, the normal behavior for the Ziti name server that's available from your tunneler is you get an IP that's automatically configured in your OS, so it uses that one first, and any answer it gets back is quote authoritative in the DNS sense,
that's right.
meaning
And
it doesn't answer other things. It says nope, there's nothing here. I'm not authoritative for that, so you have to ask another name server.
yeah, exactly. And like I said before, it doesn't need a valid top level domain. So if you wanted to create these entries and give them to your friends, your mother, your family, whatever, that don't actually resolve anywhere on the open internet by anybody, Cloudflare, Google, whoever, you can absolutely do that. And so all that, if you were not on OpenZD, they would just see these crazy DNS requests to these places that don't exist. And then when you're on OpenZD, all of a sudden you can resolve these crazy DNS names. That's pretty cool.
Right,
As far,
because it's not part of the global DNS.
that's right.
It's
Not at all.
a
It's part
Ziti
of
DNS. It's your own private
it's
DNS.
your DNS. That's
So
right.
you
And
can invent fictitious top level domains all day long.
that's right. And good to go back to the authenticated part of that equation. Since it is OpenZD, you must be authenticated before you can connect to OpenZD. Again, going back to zero trust principles. And then if you are ever unauthenticated, well, then suddenly you don't have access to those services and they no longer resolve because the tunneler will remove them for you. So that's private DNS. And that's a pretty cool superpower of a tunneling application. Cool.
Totally.
And cut. All right, let's do another one, Ken. All right, I'm going to just go right through my little slide deck. If anybody out there hasn't seen my presentation, who hasn't? Everybody's seen it, right? I'm just going to go through those slides. So
Is
here,
that pretty much what you're looking for as far as
I
coming
think that
back?
wouldn't. I think that
All right.
went pretty good. We're going to be able to cut
Okay.
that up and turn that into a 5 minute little what is private DNS, right?
All right. Let's shoot.
Trying to figure out how to make without having to paw through all my slides. I want to just jump to a slide. How to end the slideshow? I might just end the slideshow because this is just. Oh, there we go. There we go. I did it, Ken. Did I do it? I did it.
I see
All
the
right.
beast.
Okay. So, Ken, let me tell you another superpower of OpenZD. This superpower is one that we like to call build it in, don't bolt it on. And so the superpower is that your security is hidden inside of your application. So with OpenZD, you can take an SDK, jam it into your application, or integrate it would be a better term, into your application, and then your all these great zero trust strengths that are pillars of zero trust: authenticate before connect, authorize before connect, authentication policies, all that sort of great goodness that you get with OpenZD is all built into your application. It's not bolted onto your application.
Right.
Most
So often
networking.
it's like so often it's like get it working and then make it secure.
That's right. Yeah, and you think of that make it secure as bolting security onto your application or around your application. So, on the top here we have a picture of the limousine that the United States president drives around in. It's called the Beast, as you said, and it's got all this great security built into it: bulletproof tires, bomb-proof doors, glass, all that sort of stuff. But you'd never know it because it's all baked into it, as opposed to that Mad Max style of security where you're just slapping things on time after time. If some new intruder gets into your defenses, you add a new defense, and so that would be uh, integrated security, building it in versus bolting it on.
That makes sense. So I mean there's two layers here on this onion. The most obvious thing is that the beast is beautiful. I mean, Mad Max is beautiful too in a very different
In a
way,
different way,
but
yeah.
in a very different way. I love a good um, what do they call them?
Apocalypse.
Yeah, apocalyptic tale. Um, um, Something like anyway. But there's the fact that it's beautiful. There's the fact that it's unassuming, and it looks like a normal limousine. But the next layer there is that if you wanted to change something about the limousine, yeah, you have to take into account its architecture, but you could just paint it a new color, and like painting it wouldn't be any different than painting any other car, really. And if you needed to work on the engine, you could just do that anyway. There's a certain flexibility that may be a subtler point about that embedding of the security in the design, to extend the analogy, whereas there's a certain rigidity and encumbering of bolting on, where now you've got things that weren't part of the original design bolted on, and they impede working on the vehicle or changing its
I like it.
appearance, design.
It's a fun way to think of it because, in a lot of ways, OpenZD is about empowering the developer, and as the developer, you're integrating that SDK into your application, and so you are the best one to know your application, understand your application, not, the person who has to build or bolt the security on after the fact. So that's a good point. I like
Cargo cult, that's what I was trying to think of.
it. Cool. All right. Whoops. Let's see. And scene, let's go to the next one. I got to figure out how did I, oh, I can just page forward. Okay. All right, Ken. So another great superpower of OpenZD is the ability to have direct addressability. What does that mean? Well, uh, if you are really, really lucky and you have a load balancer that knows how to forward the incoming IP address, well, you can get information at your server about who's trying to connect to you, right? So in the past, as a developer, if I wanted to connect to my application, I'm going to most likely I'm going to use some sort of DNS name, and I'll have registered it somewhere. It'll be available, and that DNS name is going to map to an IP address, and I'm going to send my traffic over layer 3 or layer 4, whatever, and it's going to reach my application. And when it reaches my application, so that's how I addressed my information to my application using DNS or an IP address. And when it gets to that application, I'm if I'm lucky, I'm going to have a load balancer, like I said, that forwards the incoming IP address, and I can get a little bit of information about who is trying to connect to my service before I've authenticated them. Now, if I'm unlucky, my load balancer will not forward the incoming IP address. There's a header that gets added on in HTTP. It's X forward 4, I think is what it's called. That does this sort of work. And if I'm lucky, I get it. If I'm unlucky, I don't get it. And if I'm really unlucky, then I have users who access my services through some global VPN or from the corporate network or from wherever, and then every user looks like the same user, and I can't make any inferences there at all. And so, being able to make any kind of determination about who is attaching and coming into my service is absolutely impossible. In fact, so impossible you generally
Yeah.
can't do it.
Yeah, in
And
terms of like asymmetric warfare, is just not in your favor because you're very
definitely not.
exposed,
Well, every
and
time you
you
go through
don't.
something that nats, you lose any ability to figure out who it is who's attaching to you ahead of time, right? Now,
Exactly.
contrast that with OpenZD. With OpenZD, strong network, strong zero trust principles, authorized before connect, strong identity. You 100% know who's knocking on your door before you even let them at the door, before you even let them into the house or whatever. I'm bad analogy. I'm trying to do the whole authorize before connect motif, but with OpenZD, you know the strong identity that's trying to connect. So that strong identity is able to be identified. This is from Clint, and then Clint in that application that's trying to dial. In this case, we're using Jenkins as our example. Clint is able to say, "I just want to dial Jenkins." I don't care where Jenkins is in the world. You can pick Jenkins up and move them if you want to move them. You can get a new IP address. Layer 3, layer 4 melt away in an OpenZT world, and you get this wonderful addressability capability for free with OpenZT. Does that
That
make
makes me
you
think about physical versus logical. Like with when you're using when your ability to talk to something is based on your IP address or the zone that you're in, there's at least a loose coupling there to your physical circuit, your location. You know, like this is a logical abstraction that is software defined, and it flattens the network. So the only thing
yeah,
that keeps you from talking to something is whether your identity has permission, and it's a strong identity, not some weak identity trust factor like you're in the building or you're on the VPN in the user network or you've got some IP address that happens to have an exception in the firewall. So it creates a much more flexible and logically defined flat network where we can start thinking about everything as a potential peer if it's allowed to talk to each other rather than only client and server, where servers are normally visible and clients are not.
and in this conversation, I think of a new superpower, one that I want to add onto my slide deck, which is about reach. Because you had talked about the basically the overlay versus the underlay, and we talk about multi-cloud a lot at NetFoundry and OpenZT, and how easy OpenZT makes multi-cloud, makes private cloud to private cloud, right? It makes all of that just incredibly trivial. So that's actually a secondary superpower I don't have a slide deck for, but I'm going to put a
Yeah.
slide in for reach because I have glossed over reach for a year, even though that's such an amazing superpower of ZD. So
You mean
hey,
like reachability, right? Like,
yeah, yeah,
like
we're
host something on your phone if you want to. I
it
mean, there's some
literally.
limitations, yeah.
But are there? I don't know how. Like it's
Maybe
literally
liveness or
there's no
bandwidth, but
no.
there's a
Well, that's I mean,
significant amount of
but
compute and bandwidth available. Yeah,
For sure, and that reach is an absolute superpower. So you want to fire up a Docker container in your local and at your house and give me access, we can do that. You want to fire up Kubernetes in some cluster and give me access, you can do that. You want to fire up your own private server somewhere and give me access, you could do it. It literally doesn't matter. All you need is outbound internet, and
right.
you're able to address whatever you're trying to address.
Yeah, you say
Super, super
outbound, but the
cool.
result of that is that the thing that's doing the outbound connection is like tethered onto this overlay. So it is addressable, it is reachable by its peers if they have permission, even though it's underlay, it's like physical access is outbound.
I might start saying all you need is outbound internet connectivity on the underlay, or somehow put underlay in there because my brain just implies overlay. So yeah, the overlay has
Right,
that reach. The underlay, you need outbound underlay access, and then you can have bidirectional overlay access. So
exactly.
yeah, cool. All right, I like that one. Let's see next. Okay, so Ken, let me tell you about another great superpower of OpenCD, and that is that it's not just for clients; it's also for the server. Too often, in my opinion, we think about the walled garden that is the VPC or the data center, wherever we have a DMZ and that thing's untrusted. I want to lock that thing down. But once you get to the GUI center of my network, you could do whatever you'd like because that's now safe and secure. And I think we
Yeah.
I think we both know that's a bad assumption, right? The whole root of zero trust is that no network is safe. I love the adage that networks were meant to share information, not secure information. It's absolutely true, right? So the reason you have a network is to give people access. That is its job. Um, so all too often we think about the server in the server center or the data center being safe and secure, but really we need to stop that whole entire mentality. And we stopped thinking about that like 10 years ago, and probably only 10 years ago, where we started using TLS everywhere, right? Like that was the first step that people were like, oh, stop using FTP, as I show here. FTP is insecure. Don't use HTTP. Upgrade that to HTTPS because secure protocols are obviously better. But as long as you have a port listening inside of your walled garden, you still have the opportunity for attackers to get into that walled garden and then start expanding the whole land and expand motif. So if you add an OpenZD SDK into your server, you can actually hide all the ports entirely from the underlay, and you can start listening exclusively on the overlay, where the overlay network is that OpenZD network, the underlay is that TCP layer 3, layer 4 type stuff. So
Right.
that's an absolute killer superpower of OpenZD.
Yeah, and when you say listening on the overlay, to put a finer point on it, what you might mean is that instead of listening on any network, including the LAN, that is the private network, the directly attached physical networks, um, you're not listening there at all. So even if the another device is adjacent with an IP address in the same subnet, it still can't talk to even,
Go
it
further,
can't
Ken.
even reach the
Even
like the
even
login
a
page of that
even
app.
an application on the same server can't do it. You went to the IP and subnet, like
Well, that, yeah,
even
that just
even
depends on
an
how it's being hosted, though, right? Because if it's embedded, yes, but if it's tunneler, then it's still listening on the loopback,
we are
presumably.
talking about application embedded superpowers. So we're not talking
Oh,
tunneler here, but you're right.
okay, yeah,
Yep.
but you're no, you're right then. Yeah, two different processes on the same device cannot talk
Can't.
to each other if they're not permitted through the zero trust. Now, I do want to acknowledge a couple things we glossed over there because there is a reason why we have these secure enclaves, right? First of all, it's convenient. If you're standing stuff up and you're like, I put up a firewall, my job here is done, everything can talk to each other on a subnet, all I need is IP address management. And that's like the old school of thought that you were just saying, it's kind of being replaced by zero trust mindset and principle. And the other thing is that, as an infrastructure engineer, you might be thinking, well, I've got this storage array and I've got all these apps that need to use it, or databases, this is bandwidth intensive, this is latency sensitive. We can't be routing things to space and back, or my app's going to not function, right? There is a solution for that, and it could be represented here as one of these little ultraviolet Zs. That would just be another piece of ZD software, another piece of open source software we call a router, and it can serve as a quote local intermediary. So that smart brokering of high bandwidth channels, totally a thing, totally part of the stack.
Cool. Done. All right, next one. Let's see. I'm gonna skip through poor old log4shell. Oh, I love the let's see. Log4shell, CVE. Okay. Ken, let me tell you about another great superpower of
What have you
OpenZD.
got?
Oh, this one is pretty neat. This one is server to client. So I come from the IoT space. In the IoT space, oftentimes you'll have probably one of three options. I don't know if there's a fourth option nowadays, but there were three when I was there. You will do polling, HTTP based polling, very old school. You will do HTTP long polling, which means you open an HTTP request and you wait forever or for some very long amount of time for the server to respond, and then you instantly long poll one more time. Or you'll
Okay.
establish a WebSocket. And those are great ways of getting an IoT device to be able to talk to the server in some fashion. That's also in a server, in a web world, there's a server side.
WebRTC,
No. That's different. That's peer to peer. But no, I'm thinking about the server side. Not includes, but there's a.
WebSockets.
No, I already said WebSockets. There's another way to do server to browser communication. It's called like server side events. That's what it's called. Server
Oh
side
yeah.
events. So those are the ways I normally think of, the server being able to talk to a client. Um, you've brought up WebRTC, which is kind of interesting. WebRTC is a little bit in that space, but WebRTC is not a zero trust solution. Whereas with OpenZD, you have a mechanism of any participant on the network is able to just reach out and talk to another participant on the network with no special need whatsoever. If you have an application embedded zero trust server and an application embedded zero trust client, you can let that server just directly communicate to the client. And the client has to be authorized to receive the request. So you can actually control whether or not the client is permitted to receive that request. And so that's a pretty cool superpower of OpenZD, being able to address anything, anywhere, and that includes servers to clients.
Right. So it's like overcoming one of these common challenges with with a centralized system with many distributed devices, and it's kind of like push notifications, which
Sure.
but when you want things to be timely, like I'm sure Android and iOS have had to deal with that in order to figure out some way to keep things connected and sufficiently responsive, so you get your notifications not too many minutes later. But this gives you kind of a generic way of doing that for any piece of software that's not necessarily the operating system, and it doesn't involve Google or Apple, but like your app can have those same capabilities in a ubiquitous way.
Exactly. Cool. All right. I'm going to just bring the next build up. All right. Well, Ken, here's another great superpower of OpenZT, which is end-to-end encryption. You'll get end-to-end encryption for free by just using OpenZT. And that is also true if you are using tunnelers, but in this case, we're talking about application embedded superpowers. So if you were to take an OpenZT SDK, cram it into your application and into your server, when you communicate to the app or from the app to the client, you're going to get application embedded end-to-end encryption, full all the way from start to finish. And as I like to say, your data never leaves your process space, even though it's on two different machines, right? You never have the data leave your process space when it's not encrypted. It's always encrypted. It's only unencrypted when you get to the other end. The other end is already provided for you a ephemeral certificate that is only for that endpoint. So it's not like we're resharing some keys or something along those lines. And you have true end-to-end encryption, which is pretty powerful. It also is built on libsodium, as you see here, and uses libsodium will use, I think it offers a couple options, but the one we use is cha-cha 20 poly 1305, which is built for low power, meaning not supercomputer type um, encryption. So if you have a Raspberry Pi or Arduinos, that sort of thing.
Do you happen to know if that end-to-end encryption is absolutely valuable, extremely valuable? What I'm hearing is that it's the selection of the key exchange and cipher suite is performant for low power compute specifically, and so this has a very low overhead on both endpoints and probably in the channel as well. It does raise the question for me about perfect forward secrecy. Do you happen to know if that is also a feature of this particular
Now,
set of
I
algorithms?
it depends on what you mean by it. My understanding of perfect forward secrecy means both sides negotiate an ephemeral certificate at the time of the connection. So that is what absolutely happens when the dialing side communicates to the receiving side. They will both create an ephemeral certificate and exchange the certificate using the standard, here's my secret, give me your secret, let's mix them together kind of approach. But what really drives perfect forward secrecy is the ephemeralness of the key. So one of the things that we don't support is being able to get at the key. So if you wanted to, like, you actually can't decrypt your traffic right now. You'd have to turn it off if you had to debug your traffic. You actually would have to go out of your way to enable ZD or to disable
Interesting.
end-to-end encryption.
Yeah.
So like if you look at WireGuard or Wireshark, not WireGuard, if you look at Wireshark and you look at the other perfect forward secrecy solutions, there a lot of times the application will let you, if you poke it right or if you start it correctly, it will log for you the session key of that particular session so that you can then go and plug it into Wireshark, and Wireshark will
Sure.
actually be able to decrypt that traffic. So yeah,
Right.
it's an ephemeral exchange, and I believe it's done on each dial.
Yeah, I mean, in plain English, the purpose, the outcome of perfect forward secrecy is that if your ciphertext, your encrypted traffic is captured today, it won't be decipherable no matter how powerful computers get in the future, because there's no
Well,
relationship back to. I
so
mean,
like the whole quantum thing comes into that equation, right?
well, put another way, if you are able to crack today's payload, it won't give you tomorrow's traffic. It's because it's a
Yeah,
different key.
That is for
Right.
sure, and every
Yeah.
that's the ephemeralness, the one-timiness that's really important. So
Right
yeah,
on.
every time if you create a different key, every time you connect, it's going to be very, very difficult to crack every single key every single time.
So
That's
do I have to do something special to get this end-to-end encryption? Do I have to take extra steps like we're dealing with keys or anything?
You don't. Nope. The client negotiates that with the dialing the receiver all through OpenZD. OpenZD takes care of all of that.
So this is networking software in any kind of traffic, any kind of app. I can get end-to-end encryption basically out of the box for any
If
kind of.
you embed OpenZD into your app, then yes.
Okay.
So if you are using a tunneling app, for example, you are mildly susceptible to local sniffing. So
Sure.
if you're using a tunneler, the traffic that before the tunneler, it's up to you to make sure that that's actually secure. If you're not, and if you're using an app embedded, then you get it end to end for free just by using OpenZD
Right. Okay. So it's on by default.
on by default. That's right.
Cool.
All right.
Amazing.
Okay. I don't know how if I want to do the build. I'm gonna. What do you think? Should I do the build? Which one of these do you think is a better slide? So this is about port
Inference not
inference.
allowed.
Yeah. So
Current
so basically,
inference.
what happens?
Oh yeah.
All right. Let me. I'm gonna do the build. Here we go. All right. All right, Ken. I got another great superpower of OpenZD for you, and this
All
one's
right.
around port inference. And what does port inference mean? Well, if you take a look down in the lower left-hand part or lower right-hand part of the screen here, there's a little link that shows you what the top scanned ports are. And so if you go out to any network and you attach a scanner, you're going to see traffic like this. You're going to see SSH traffic. You're probably going to see a whole bunch of port 443 traffic. You might
Right.
see database traffic, and you will see MySQL up there. You might see file share traffic. You'll see a lot of traffic. You'll know the sorts of activities that people are
Sure.
doing on that network. You'll know what sorts of where you'll know what IP address the file server is on, so
And
you
the name
can
server.
all of right. You'll know
Yeah.
you'll be able to discern a fair amount of information by being able to attach a sniffer like this and
Totally.
gets yeah. So where OpenZD's superpower comes in is with OpenZD you cannot do that. So with OpenZD, port inference is just simply not allowed. Everything will look like it's port 443, and it does
Right.
that because when OpenZD connects to the OpenZD network, when a client connects or an edge client connects to the overlay, what will happen is a synthetic connection will get created. And generally speaking, probably people are going to use port 443 for the synthetic connection because it makes it more difficult to discern where that traffic is coming from and going to. It looks like any regular port 443. But all of the traffic that is captured or sent through OpenZD will all
Mhm.
appear as though it is port 443. And this actually is a superpower that is not exclusive to application embedded zero trust. This is also a superpower that pertains to the tunneling applications because those tunneling applications are SDK applications. You're going to get this exact superpower as well when you run a tunneling application locally. Um,
Right.
Anybody who's able to attach a port sniffer to your machine will know what you're doing. But if they're running on your machine, then you maybe have different problems.
Yeah,
Uh,
absolutely.
yes, so that's pretty
Yeah,
neat.
and
That's
so
port inference. Oh yeah, go ahead.
it's kind of a networking question, but someone might be wondering, well, now that you're shoving everything through the same port, do you have just as much bandwidth available, or is it like going to like choke on port 43? And I would just reassure them that you don't have any. There's no bottleneck represented here. A port is just it's just a flag, and it's just bits in the packet that's determining like source or destination. So you can get just as
Yep,
much bandwidth through on where everything's on 443.
you can totally saturate a network with a single socket. That is absolutely true. Yep, great, good point. Okay, Ken, I got another superpower for from OpenZD for you. This
All right,
one
what's all this?
This one is about ease of use. So as you can see here, we have some Java. So maybe you're familiar with Java, maybe not. But if we just boil this down to the salient bits about why this is so easy. You can see same sort of looking code on the top. I need to understand what address I'm going to listen on. So I need to know my IP address. So some person has to tell the developer how to configure the file, or that person has to know how to configure the server or the application you're going to deploy, and they'll have to decide what port it's going to listen on. And that's how you would do it before ZD. Well, after ZD, all you really need to know is what service do I need to use in order to listen on whatever I'm trying to listen on. In this case, we're showing a server example because we're running the
Right.
bind example. So that's it with Superpower ZD. So easy to do. No IPs needed to understand by the developer. No port required. Just say, I want to listen on my service, and then let other OpenZD clients connect to that service. Easy as that.
So the server SDK, as a pattern, as a rule, will elect, they will opt in to begin hosting some service by name. And
But
then
well, so I
if
would
they're allowed
say,
to, then they will.
yeah, and I would actually turn that in a little bit, because any program can be a server. It just depends on if the program indicates that it wants to listen, right? So, and you do that right here with this bind command that says, I would like to be able to listen for incoming requests. And so, yeah, that's basically what defines a server.
In a nutshell, right here is the difference between using an IP as an identity or as configuration versus an identity, because that service has an identity too. And you have the identity as the server, as the hosting SDK, but it's cryptographic and configured instead of using an IP. So you got that flexibility because you can always program the the policies later.
Yeah, and yeah, and to your point, and I think we have a comment here. It says also the same thing, which is policies can influence whether or not it's able to, right? So that goes back to the other zero trust goodness that OpenZD provides, is that ability to have finer grained control on, what your identities can do, what sorts of um, powers? No, I don't want to say powers. What sorts of capabilities? That's the word. They're able to perform based on these interesting policies that OpenZD provides.
Right.
Great. All right. Well, Ken, I think that's most of the superpowers. We'll be able to cut that up and make it into some nice little snippets. I don't know. Is there a superpower that you could think of that we might miss? I like the reach
Uh,
one.
yeah, I think the reachability or reach is
Oh,
very
oh,
similar to
no,
pushing to the client.
I know one I forgot. I forgot the fabric. Let me go back.
What
How do
about
I?
it?
What's the fabric? All right. I don't have a great. I gotta.
Distributed adaptive mesh.
Damn.
What?
did you don't realize you just spelled damn, the distributed adaptive mesh. Damn, that would be my slide.
Nice.
So Ken, if you see a
Well,
damn slide coming out, you'll know where it
yeah,
came from. All right, well,
we
let's
need
go
an
back.
acronym for our patents, right?
Let's go. That's right. Let's go. Damn, let's go back. All right, so let's see. Ken, I got one more really interesting superpower of ZD, and that is this thing that
Okay.
we call an overlay network and a mesh overlay. So I'm going to blast through these slides kind of quickly, because
All right.
really, when I say an overlay network, I'm really just talking about ZD itself. So here I'm showing you the internet, but really the overlay network can be considered the internet, because that superpower with ZD, all you need on the underlay network is outbound connectivity. You need to open no firewalls, and that's because we have this whole mesh network that you connect your edge into. And so a mesh network consists of a controller, and it consists of some routers. Those routers are all interlinked and form this interesting mesh. That mesh knows how to route your traffic from one layer to the next, or from one destination to the next destination. Does that securely, all using mutual TLS like this, because I've removed some of those noises. Because what we're trying to do here, we're trying to get our packets from point A to point B as fast as possible. And so that is a superpower of OpenZD. You get this distributed adaptive mesh that has this great control that you're able to exert over it once you get to the point where you want to learn how to exert that control. And that's a pretty cool superpower of OpenZD.
Everything on the overlay is bidirectional.
You know, thanks for mentioning that, Ken. Thanks for ruining my slide. I've thought about that as well because this traffic is only going one way, but that's an excellent point.
Well, you get
And
your arrows
the
pointed both directions, so
I do,
it's
but I don't have any
bidirectional.
traffic coming back. So I when I presented this slide the last time, I was like, oh, I really need some traffic that goes the other direction just to hammer the point home that this is actually bidirectional traffic. So it's a good point. In fact, I might make the traffic coming back go a different path. I don't know. All right, cool. All right, that's our last superpower. So let's go back to do. Whoa, all right,
There's a
this one.
capability that we might be able to fit in there. Todd was chatting me up about the portability aspect. So where, like when we were talking about building in versus bolting on, maybe this is maybe this is something we could tack onto that idea, because like if you're bolting on security, then you know how we mentioned the rigidity that represents. You can't really change one thing because then you have to change everything else in order to align with it. Whereas if it's deeply embedded, then you can just take the whole thing and move it somewhere else, and it functions the same way as you said, as long as it has basic commodity outbound IP. That's all it needs. Like any kind of internet circuit, no special configuration, no relationship with its environment. It's super flexible and super portable like that. You can run your app anywhere, in your closet, at the data center, on your phone. It functions, according to whatever resources it has available, not relying upon special, crusty kind of configuration.
Hmm. Yeah. Okay, I'm going to try to fit this last one in because this week on Discourse we had a great conversation about end-to-end encryption, and we had a user who was slightly confused about, if Ziti provides for me end-to-end encryption, why why is it that I have to worry about somebody on my local network sniffing traffic? Shouldn't I be immune to somebody sniffing traffic? The setup around this was we have a tunneling based application running locally, like I have my tunneler running locally, and mine's running Windows right here. Right, there's my Windows tunneler, and so they were running a they were running a tunneler locally. They were sending their traffic over ZD to the other end, and then once at the other end, they had actually embedded the Golang SDK into a server. They took one of our samples and made an HTTP server, and they had
Mm-hmm.
created a reverse proxy, a zero trust reverse proxy, effectively. Um, Once the traffic landed at the HTTP server, they then would forward the traffic to the actual destination. Right
Okay.
now, at first glance, that is shockingly similar to what a ZD Edge tunnel would do. So if instead of having let me put a little, I'm going to put a diagram up, and I don't know if I'll be able to edit it at the same time or not, but like here's the little diagram, and
Oh yeah.
so on one side over here he had a tunneler. And I actually, if I go like this and I go like this, I can go like this. Oops. So, all right. So he had the tunneler right here. And then on the other side, instead of a tunneler, he actually had written a Golang Go HTTP server, right? And so he was, because it's easier, he was using HTTP on both ends to send traffic from his tunneling app to his Go app on the other end. He
I
asked,
see.
"Hey, if I were to get any questions about this, what do you think? Is this secure?" And I said, "Well, it depends. If you're offloading your application traffic from that Go server somewhere else, something, where's my arrow? Come on, arrow, right there. Something along these lines to the actual, let's see, call it actual. So if you're offloading your traffic to something actual and that traverses a network, let me add a little. Do I have a network cloud? Where's my cloud? Can I make a cloud? I don't have a nice little network. What do you use? Oh, there we go. What do you use for a network symbol? Let's do it like this.
Uh,
I don't know how to make that. We're going to do it like that.
a
Network.
nebulous network zone.
Yeah. So if you were doing something along these lines where you have your your traffic going through the network, not all entirely local, well then anybody on the network, so say somebody on the router would be able to intercept the traffic and determine, where it's going to and see it in the clear because we're
Oh,
using
right, right,
HTTP in this position.
right. You have no true end to end, whereas your
That's
yellow
right.
pipe, if it was HTTPS, would be true end to end.
Exactly. Yeah,
Because
but
that's the actual
also
application that you're delivering
that's
here.
right, and that's the little mind leap that you have to make right there is if you are off now, this is also true if you were to take this into a proxy, like this Go HTTP server, I'm gonna like plug it onto the tunnel now, right? We're gonna go like this so that it's actually part of that little tunnel. If it is sending in HTTPS, so if we do HTTPS and we make this a Go HTTPS server, but if we're still sending HTTP to the actual, like if it is doing a man in the middle type of or as a load balancer would call it, TLS termination, right? So if he's terminating TLS at the HTTPS server and then decrypting it, aka terminating it, and then forwarding it on himself by making some new socket and sending HTTP, not HTTPS traffic, well,
Right.
then he's also susceptible, right? That would also be a problem. So, what's a little mind leap that you have to go through is that really you want the HTTPS to go all the way to your actual, right? Why can I have to click in there, right?
Well, is the so this reverse proxy that he's created is a hybrid animal because it is embedded. It's app embedded on the front
Yeah,
side
and this is
of
where
the
it gets
reverse
really,
proxy, but
yeah,
the backside, it could be a totally different
100%.
TLS situation, right? And
To
normally
totally.
is because
Totally
it's from front
100%
end to back
agree.
end.
Yeah,
Yeah.
yeah. In fact, that's where, and so I started with this example. I was going to dovetail into that because as I was responding on discourse, these like all these little nuances I would have had to cover, and it's a lot of typing, right? So, so I didn't want to cover all that because that was not what he was actually doing. So I covered what he was actually doing. But you're right,
Okay.
and I see in the comments here that it depends on if it's app embedded. That's exactly right because you don't need HTTPS at all from the tunneler to the Golang HTTP server, right? So if we do this, and this is still HTTPS, let me bold it like this. Actually, if I spin it, it'll be easier to read. Oh, that's even better. So if it is HTTPS from here to here, well, then you are secure from the tunneler all the way to the Go HTTP server. However, this is all server side, right? There is the next
Yeah.
layer of the onion, which is the client side, and this is what your browser sees, right? So when your
Yep.
browser connects to the tunneler like this, even if you have HTTPS here, if you're sending HTTP on the yellow pipe, and you know what? Let me turn the old pointer on, laser pointer.
Yeah, that's helpful. And the
If
arrow
you're
is a little bit hidden on the back end, on the
Oh, it's
upstream.
yeah. Well, we were doing this live, is I need to turn this into an angle connector. I wasn't going to do it, but since you're
But yeah,
asking,
these one way arrows are important here because it describes who's trusting whom.
is it a whom or whom? All right. So
Who's he
yes,
trusting? He's trusting him, so it's
right.
whom.
It's whom exactly. So you got a grammar lesson in here too.
Yeah.
So the real problem is his users are going to see HTTP in this example. They're not going to see a padlock in this example because the server on the far side, even though you're doing end-to-end encryption the entire way, is going to then present to the browser as HTTP and no padlock. And so
Right.
this little link right here, if you're on the local machine, you could sniff that traffic. So anyway, I
Because
want to
a reverse proxy is a transparent proxy. That is, the client is not aware that it's talking to a proxy. It thinks it's talking to a normal web server. So it's going to see plain HTTP.
Yeah. So I wanted to cover that in a video because I thought he probably would appreciate, hearing some words, seeing the diagram, talking about it. And it is a nuance. And if you had now to add to that nuance, to go back to the point that Andrew made, if you have an application and that application has, I'm going to send this to the back, and that application has Ziti built into it, right? So if you were delivering an app as opposed to the browser, then you're still secure, right? This will be absolutely end-to-end encrypted, unsniffable, because your app is using Ziti to send HTTP, but that HTTP is over the end-to-end encryption because the end-to-end encryption actually happens at this layer, right? So like this is where the end-to-end encryption is coming from. It's coming from Ziti, which is in the app. So that's yet one more layer onto the puzzle to kind of get into the brain and understand. Anyway, I wanted to cover that because I think that we can snip that out and make that a nice little short video for him as well.
Cool.
All right, that's the end of our Ziti TV on May 6th,
Yay.
2022. We did it, Ken. We made it. Whoops, that's the wrong button. I wanted to do this. So thanks everybody for hanging out. I see we've had some people the entire duration. That's always great to see. Appreciate it. Um, any questions about Ziti, hit us up on Discourse. Oh, we need to start doing like a little, thing at the end, Ken, right? Where boom, visit us on Discourse at openziti.discourse.group. You can find us on Twitter at OpenZiti. And I'm Clint. That's Ken. It's been Ziti TV for another week.
Yeah, let us know if you have ideas for future topics,
Ooh, on
episodes.
Discourse.
There's a place for that on Discourse. Just search that Discourse for ZDTV.
Awesome. All right. We'll see you, Ken.
See you later.